Solving systems by elimination notes. Notice in these systems of equations that the x variables and the y variables and the constant values in the equation are stacked up on top of one another. So we have x's on top of x's, y's on top of y's, and numbers on top of numbers. Okay. When that is the case, we can use a method for solving the system that's called elimination. And basically, what we're going to do, after I erase these, is we are going to add these two equations together and hope that one of the variables cancels out. Now, I can only add like terms, so first I'm going to add negative 2x and x, and remember there's a 1 in front of that x, so negative 2 plus 1 would just be negative x. Now notice I have a positive y and a negative y. When I add those two together, they cancel each other out. Okay, so that would be just 0. And then 4 plus negative 2 would just be 2. Now I have an equation with only one variable, so I could solve for that variable. And remember, negative x is really negative 1x, and it's times. So to solve for this, I would divide by negative 1 on both sides, which gets me x equals 2 divided by negative 1, which is negative 2. So I am already halfway to my answer. I have the x value of the point of intersection. And now what I need to do is take that x value and plug it into either one of those equations above. Now, we've done this before with the equal values method and with substitution. But in this case, the solving is just a little bit more difficult. So I'm going to take that negative 2 and plug it in for either x. It does not matter which equation you choose. It'll work in both. So let's do the top one. So I'm going to rewrite the top equation. And I'm going to plug this negative 2 in for x. So instead of an x, I'm going to put a negative 2. I highly recommend, that's y. I highly recommend when you plug in that negative 2 for x, you put it in parentheses. Now I'm going to do negative 2 times negative 2, which would be 4. And then I'm going to subtract 4 from both sides. And 4 minus 4 is 0. So that means that the y value of the point of intersection is 0. So there is my final solution, negative 2, 0. And I could double check that if you want by plugging it into the other equation. So the second equation up above was x minus y equals negative 2. And I could plug negative 2 for x and a 0 for y, and then see what happens. Well, negative 2 minus 0 would just be negative 2, and negative 2 equals negative 2, that's true. So I just proved that negative 2, 0 is a solution to the second equation as well. So that is the final solution to my system of equations. So when we're using elimination, the first thing we're going to want to do is make sure that the variables are stacked. Let's do this example on the right. And again, the x's are stacked up here, the y's are stacked up here, and the numbers without variables are stacked up over there. So when that's the case, we'll simply add these two equations together. And notice that 2x and negative 2x will cancel each other out and give us 0. And then I'm going to add the y's. So 2y plus 5y would be 7y. And then 14 plus 21 would be 35. And now after I added those two equations together, you'll notice the x's disappeared from the equation. So now I just have an equation with 7y equals 35. So I can find the value of y by dividing both sides by 7. And I get y is equal to 5. So again, I'm halfway home with my answer. This time I found the y value first of the point of intersection. So now I'm going to take that y value and plug it into either equation. And it's your choice, so I would pick the equation that looks the easiest to solve. And I'm thinking the top equation looks really good because there aren't any negative signs in it. I like to keep things as positive as possible. So I'm going to take that top equation, I'm going to rewrite it. And then I'm going to plug this 5 in for y. And remember, when we do this, it's a smart move to put it in parentheses. So now I would multiply first, so 2 times 5 is 10. Then I would subtract 10 from both sides. Now I'm just solving for x. I get 2x equals 4, and then I would divide both sides by 2, and I get x equals 2. So that's the second half of my answer. So the point 25 is a solution to this system. And again, we could double check that by plugging that point into the bottom equation and see if it works. So it'd be negative 2 times the x value, which would be 2. And it would be 5 times the x value, or y value of 5, equals 21. So negative 2 times 2 is negative 4, and 5 times 5 is 25, and negative 4 plus 25 is 21. So since it worked, I know that I just verified that 2, 5 is the solution to this system. So let's look at another example. And remember, since our variables are stacked up on top of one another, I'm going to add the two equations together. So 2x minus x would be x. And notice that positive 4y and negative 4y would cancel each other out. And 46 plus negative 41 would be 5. So this time, I have nothing else to solve. It's already done for me. It's just x equals 5. So that means I have half of my solution. And now I can take that x and plug it into either equation. I'm thinking let's plug it into the top equation again because remember, it's all positive. So I think that would be easier to deal with. So I'm going to rewrite that equation. And then I'm going to plug in x is 5. So that x is going to go here. And remember, we plug this in with parentheses. And now I'm just going to solve this equation for y. And so it's a little bit more work. So 2 times 5 is 10. And then I'm going to subtract 10 from both sides. Hopefully you remember your solving skills. So it's 4y equals 36. Divide both sides by 4. And I get y is equal to 9. So I plug that into my point, and that is my solution. And if you want, you could plug that value, those two values, into the bottom equation and see if they make it true. And they will. That is the answer to the system 5, 9. Let's do one more example. And we're going to add these two equations together, remember, because the variables and the values are stacked. So negative 5x and 5x would cancel each other out and be 0. 4y minus 3y would just be y. And negative 29 plus 28 would be negative 1. So again, I'm already halfway home. I know my y value is negative 1. And now I'm going to plug that into one of those two equations and solve for x. I'm going to plug it into the bottom one this time. So into this equation. So I have 5x minus 3y equals 28. And then I'm going to plug that negative 1 for y. And remember, use parentheses. And now I'm going to multiply these first. So negative 3 times negative 1 is 3. And then I'll subtract 3 from both sides. And I'll get 5x equals 25. Divide both sides by 5. And I get x equals 5. So that is the second half of my solution. So that is elimination. We use this method, remember, when the variables are stacked up, where the x's over x's, y's are over y's, and the numbers are over numbers. And then I just use addition to add the like terms, and then hope that something cancels out, which allows me to solve the system.